Okay, let's take a look. Says retailers buy 45 cordless phones from a wholesaler of a price of $10 each, and will buy 20 at a price of $60. Wholesaler will supply 35 phones at $30 and 70 at $50 each. So supply and demand. Basically, what we're looking at is this. So this goes along with number 10. So we got to plug in 45, comma 10, and 20, comma 60. Retailers will buy cordless phone, 45 phones from a wholesaler, 45 at 10, and buy 20 at a price at 60. Okay, so this is going to be one equation it's going to create. And then a wholesaler will supply 35 phones for $30 each, and 70, the wholesaler will supply at 70 at 50 each. So we're going to create, so we have supply and demand. So retailers will buy from a wholesaler, assuming supply and demand functions are linear, find the market equilibrium point. So remember, the equation that does this will be a demand, and the equation that does this, as far as when it grows, this will be supply. Okay? And our best friends, the Desmos family, that we all have grown to love, maybe not, but I enjoy them. So go to our table, and we're going to do 10 and 20. Oh, wait, wrong place. That's 45 and 10, and then 20 at 60. Did I do that right? 45 at 10, 20 at 60. Cool. And then I can go y sub 1 tilde mx sub 1 plus b. Okay, and so we do that. It's going to take us there. Let's darken it so we can see the beauty. There's our first one. So that equation is a demand because it's going down. Then I'm going to create another window. That will go another table. Yeah, it worked. Oh, best AS. All right, so 35 at 30. At 30. And 70 at 50. And then I'm going to make another equation. So rather than using y1, I'm going to use y2 tilde.
Well, but wouldn't you already know that 45 and 30 is on the line?
Yeah, oh. Were they both on the line?
No, oh, well, the 35 and 30 dot is on the line.
Oh, we're lucky.
Wait.
Plus b. Okay, yeah, so yeah, that's your point of equilibrium. So basically, assuming the supply and demand function is linear, find the market equilibrium. 35, 30 is your equilibrium point. But the main thing is realizing when you have multiple tables, realize what your subscripts are on your table, and that's what you're going to plug in. And then number 11 says, suppose a certain market, the demand function for a product is given by T, P plus Q equals 2300, and the supply function is 45P minus Q equals 360. If the government levies a tax of $2 per item on the supplier, who passes the tax on the consumer as a price increase? Find the equilibrium price for the quantity after the tax is levied. Ooh, $2 per item. Okay, so we have P and we have Q. So Q are supplied. Price. Okay. So let's get rid of these. Boom. All right. So I'm going to change the prices because it's $2. All right. So P is our Y value. So we have 10Y plus X equals 2300. Let's just do these first and then we'll take a look at them. And then we have 45P minus X equals 360. Let's figure out, oh, sorry. All right, there's one graph. There's our other graph. I'm just going to head out here. So this right here is our point of equilibrium. All right. Now it says, I got an email. If the government levies a tax $2 per item on the supplier, okay, so our supply graph is going to be the red. So we're going to increase by 2. So I'm going to, how am I going to do that? You know what? I'm not a fan of this problem. I would just, in this problem, I wouldn't throw that out. I'd just give you the point of equilibrium and you could just find that where it crosses.
Oh, I just said you would add 2.
Yeah, I was thinking about that, but where do I want to add a 2?
To your final price? Because they're giving it to the.
So 1818?
Yeah.
I don't know. All right. Let's see if this one goes well. Yeah, I wouldn't worry too much about 11. Suppose the total cost function for a radio is linear. The marginal cost is $27. Total cost is 50 for the radios. Write an equation of this cost function and then graph it. Okay, so I'm going to go back to this real quick. There. So for number 12, we know that our cost is basically the revenue. The revenue is just they sell $50 per item. And then we have the total cost is, well, go to the right one, strip. And the total cost ratio is 4350. So the marginal cost is 27, which is what do you guys do here? Let's see, number 12, 27 x plus 3000. All right, so total cost of 50 radios is, so if I bought 50 radios, that would be at 4350. So that's X and Y. And we know the marginal cost is 27. So marginal cost is 27X. All right, so let's figure out, why am I being dumb? Like, Strip, we don't know. You just are. XY, that's our slope. I think we can do this. Y minus 4350 equals 50x minus 50. So you could just plug that in right there. Let me write that down so I can, let's flip back and forth. Yeah, actually, I would say you're done there. I mean, there's no reason to solve this for y, because you can plug that into Desmos as is. You don't have to even graph it. I know it's different than the answer, but basically, if I go 50 times negative 50 and then add the 4350, it should work out, I hope.
So if decided to work out through that, then that would be fine. But
Yeah.
you could also just leave it there.
Especially because Desmos will take it. And then a company distributes college logo sweatshirts, sells them $50 each. So 13. So our revenue of cost is 50 times X. The total cost function is linear. The total cost for 100 sweatshirts is $43.60, whereas the total cost for 25 sweatshirts is $76.50. So you have to, I would use Desmos as a table for both of these. And Desmos will solve that for us if we plug it into the table. And then the break-even point would be at x equals 80. So let's find this equation. So I have 100 comma 4360. I have 250 comma 7060. Get rid of these. Table. 100 4360. 250 7060. Y sub 1 tilde mx sub 1 plus b. And let's go find this equation. There we go. And then we can go, our revenue equation is y equals 50x. All right, so our break-even point is x equals 80. So at 80, we have 4,000. So that's our break-even point. All right, so if you're here, you're getting the points for that entire page because I think you did it. And trying to keep you guys motivated to stay here, if that's okay with y'all. All right, I am on the next page. It says if the supply company for commodity is P equals Q squared plus 100, and the demand function is P equals negative 20 Q plus 2,500, find the market equilibrium. Okay, so the main thing you want to do on those is this. So you want to make sure your P value is Y and your Q value is X. So when you plug that function in on Desmos, you're going to get Y equals X squared plus 100. And then you'd also get Y equals negative 20X plus 2,500. Ignore the window that they have set up. If you graph both of those, you're going to have two different things because one's a parabola. So $20x plus 2,500. Squeeze in there. And you can jump onto Desmos pretty easily. I just got to give you one of these examples and you should be good. Y equals x squared plus 100. And y equals negative 20x plus 2,500. And you want to make sure you see where it crosses it twice. So that's market equilibrium there and there. So sometimes when you have a negative value, it's not going to make sense. So you're not going to supply negative 60 items. Okay, that's kind of goofy. So in this case, you'd have 40 comma 1,700. But if you just were listing the equilibrium prices, you could list both those points. Okay? So my friends, I would bet you, why don't you finish off the page. So it's applications in business. It says profit. Boy, Stirp is struggling today. Revenue and cost. gosh, stirrup. Figure this out. All right, just type it.
So in the next one, there's another like, one that you might remember. Should you write it or should you just ignore it? Because it's irrelevant.
I would write it. Just write it. You'd be fine. Don't worry about justifying it. And if you would, go ahead and do 1 through 5. You know, the rest of the time do it. And we'll check that off tomorrow. And then Friday is a real life application.
What is it?
I don't know yet. Did you get something? Maybe.
Like something about loans.
Loans?
Like car loans. I don't know.
Which would you like, cars or houses? Cars? Car loans it is.
Yeah, that's what I did today during advisory.
Oh, cool. Up and right.